Hi, my name is Jessica Dean, and I'm a Senior Cloud Advocate at Microsoft. I'm super excited to be here today to hang out and talk about DevOps, Waffles, and superheroes. Oh my. And we're going to have a bunch of fun doing it. Now, just a brief disclaimer before we dive right in, because sadly we only have 30 minutes together. I want to let you know what this session was designed to do, so that you know what you should expect. First off, this session was not designed to make anyone an expert. Sadly, even though it's a superhero talk, I don't have superhero powers to do that in 30 minutes. But the session was designed to get you thinking, to show you some of the things that's possible, maybe things that you aren't even aware of if you are familiar a little bit with Docker and Kubernetes and microservices. It's also designed to get you excited, right? To get you pumped up. And then at the end, there will be resources where you can go and learn more. Now let's go ahead and dive right on in. First, let's level set. What exactly is DevOps? Now, as it turns out, you could ask 5 different people what DevOps is, and you would get 5 different answers. So I want to make sure that I share Microsoft's definition of what DevOps is. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. Continuous delivery of value. The most important word on this slide is value. Because if you're not delivering value, what are you doing and why are you doing it? And more importantly, how do you know if you're delivering value, right? How do you gauge it? How do you have telemetry? Especially in the world of abstraction and distributed systems and maybe decoupled applications or hybrid applications, things start getting very confusing and hard to follow. So we're going to hopefully try to simplify that here. Now, starting with simplification is actually how Kubernetes came to be. So if you happen to have been snapped by Thanos' fingers and you're wondering, what exactly is this Kubernetes? It kind of sounds like it can be a candy. It's not. It was originally actually built in partnership with Google. It was based on a system that they had used for over a decade now called Borg. And it's an open source container orchestrator. It was designed to automate deployment, scaling, and management of your applications. In short, it was designed to simplify automation. But it's quite complex and it's quite robust. And so we'll talk about other tools or other products that were designed to help simplify the simplify. First, let's do a brief overview of what the Kubernetes architecture kind of looks like. You have a self-managed main node or nodes. You can have multiple main nodes. This makes up what's called your control plane. You have things like your API server, your etcd for your database, you have your scheduler, you have your controller manager, your cloud controller. All of this stuff lives in your main nodes or in your control plane. And that control plane communicates to your agent pool, where you have a Docker engine, you have your pods. Pods can have multiple containers, and these are what's running your workloads or your applications. Now, there's a Kubernetes API endpoint that you communicate with, you as the user, through some sort of workload definition, be it a manifest JSON file, a YAML file, or a Helm chart. And we'll talk about Helm in just a second. But you define the way of the world you want it to be, whether you want all of your microservices deployed in one namespace, and we'll talk about what that means, or whether you want it deployed in a different, whatever orchestration you want it deployed, you define that. You send that over to the Kubernetes API endpoint, and then the main node or the control plane will then go ahead and schedule that and release that out to your agent pools or your worker nodes. These are the machines that's going to run your applications and your pods. Now, this is a lot to manage, in particular because you'd also be responsible for everything in that control plane because it's self-managed. You're responsible for hardware updates, for software updates, canonical upgrades, if you're running, again, a Linux Kubernetes cluster, which chances are you would be. Now, in a managed control plane, meaning that a cloud provider takes care of that for you. This is how Azure Kubernetes Service works. Azure's managed control plane is managed then by Azure. So we remove some of that burden. Now, all you have to worry about as the user is to write your application, describe the way of the world you need it to be, send it off over to Kubernetes, either with Kubernetes apply or kube control, kubectl, whatever pronunciation. That's the binary you use to interact with Kubernetes. Or you would use Helm to install. Either way, you send that over to the API endpoint, and then Azure's control plane will go ahead and distribute that to your agent pool or your worker nodes. Now, I keep mentioning Helm. Kubernetes itself is a little over 6 years old, okay? So there's been a lot of changes, a lot of things that have kind of come out to help make it easier. An interesting fact is Helm is almost as old as Kubernetes. So it is the de facto package manager for Kubernetes. You can think of it like pip, like NuGet, like apt. It's just a package manager that was designed to simplify the simple, okay? It actually came out of a hackathon project in October of 2015 by a company called Deis that Microsoft later acquired. And now we have contributors from several major companies, all contributing to make Helm a success so that everyone who's using Helm, Kubernetes, Docker, the world of microservices can have a more simple time managing your YAML files or your manifest files. And of course, so you don't have to worry about tabs or spaces errors. Now, let's go and do a quick walkthrough using Visual Studio Code to kind of see some extensions that we can use or have in VS Code to help simplify this, how we can work with Helm charts, how we can work with Docker, and what exactly Helm charts or templates look like if you're new. Also, what do Docker files look like? Maybe we'll take a look and go line by line and kind of get a little bit more familiar with this. Let's check it out. So I'm currently in Visual Studio Code, and let's just take a look at a Docker file. You can see that I have lines here that says from. In fact, I have from on line 6, I have from on line 14 right here, and I have from again on line 24. This is what's called a multi-stage Docker build, because a lot of times what you need at build is not what you need at actual runtime. So this first block of code, 6.2.12, is actually building the React component of this Tailwind Traders application that we'll use throughout today's session. This next block of code, lines 14 through 22, is building the .NET Core component of this application. It's a hybrid front-end application, .NET Core and React. And then we're copying the output from those two stages over into this final stage where we're only using the runtime for .NET Core to actually run our web front-end. Now, the cool thing is we can integrate right very easily within VS Code by using the terminal, and we could just do something like Docker build. And I had previously built this, so this would build really fast. We could also do the command palette and search for Docker, and we could see that we have some Docker commands. Now, these commands are brought to us because we have the extension marketplace. So you can see right here, if I search for Docker, here's my Docker extension. I can search for Kubernetes, and I have an Azure Kubernetes extension. This is also another really helpful extension when you're working with Kubernetes. You can also see I have local process with Kubernetes, which we'll talk about in a little bit. And we also have perhaps one of my favorites. We have the Azure, let's see, I would have to do @installed and then do Azure. I have the Azure account extension as well. Now you can see on the left-hand side here, here's where I have access to my Kubernetes clusters. I have a local Docker Kubernetes setup. I have Azure Kubernetes Service. If we go back over to our files, we can also take a look at our Helm charts, just so we kind of get some familiarity with what exactly Helm is. So we can drop down into web, and you can see I have a templates directory and a values file. Let's just click on this values file here. And you'll notice we have image, repository. Some of these have indents, right? Two spaces or one tab. And if we drop down on one of the templates and we click on deployment, you'll notice that there's a lot of references to values. That's because this is referencing that values file. So as opposed to having to manage multiple YAMLs files, that's one of the benefits of Helm as a package manager. It's simply a template engine that's going to then parse in the values that you specify accordingly right here in your all-up knobs and dials. All right, so I hope that was really fun. Now you might be wondering, again, if you got snapped by Thanos' finger, this is a superheroes talk, you might be wondering, that was really cool. I kind of am following all this YAML stuff and this YAML business, but I'm still not 100% certain what a container actually is. I understand that there's Docker, but I thought Docker was something different than Kubernetes, and all of those are really great questions. I am so glad you asked. First off, I'll hear a lot of people try to explain or compare a container to a virtual machine. And that's not really true at all, because it's not a virtual machine. It's not even a real thing. Instead, it's an application delivery mechanism with process isolation, right? Its only goal, a container's only goal, is to deliver your application and isolate the processes needed for your application. And it's based on several key Linux kernel features. So if you come from a traditional Windows background, certain words like namespaces, which I mentioned earlier, and C groups might be unfamiliar. C groups is what your process can use. That's hardware. That's things like your memory and your CPU. Namespaces is what your process can see. That's things like your mounts, and it's just things that your processes needs access to. Okay, an easier and more delicious way to think of a container is to compare it to a waffle. And here's why. Now, this picture on the screen is a little misleading because there's still butter and syrup. So let's take the butter and syrup off and imagine that it was just a plain waffle. How many of you like to eat waffles completely plain? And I know there's going to be just one of you, and more power to you. But for me, I like to have my waffles with as much fun as possible. I want whipped cream, I want blueberries, I want strawberries, I want pecans, I want syrup. It's no wonder why I have to hit the gym, which is even harder now in quarantine. But I want a whole bunch of stuff baked into my waffle because that waffle is going to be the delivery system to my stomach, and I want it to deliver value. Remember, the definition of DevOps, continuously delivering value. I want it to deliver value or happiness to my life. So if we think of the waffle in comparison to a container that is just a delivery mechanism, and all you're doing is putting the processes or the toppings, whatever you need to make that delivery mechanism valuable, that's all it is. Container is just a waffle. Now, let's do a quick recap on how Docker files work. We kind of ran through this when we were looking in VS Code, but let's make sure we fully understand how a Docker file is structured and what its intention is for. A Docker file defines the steps that you need to configure your container's environment. You use it to build your container image. You start with the base image. That's just the base that your process isolation or your application is going to need. You can set working directories, and then you can copy files from your current working directory from wherever you're building this Docker file. And we'll talk about that copy period in the next slide. You can build that over into that work directory you just specified. You run the commands you would normally run locally from your system. In this instance, we're running pip install, and you give it a requirements file. You can expose ports. You can set an environment variable for your port if your application has a process environment variable. You can set environment variables for anything, even build arguments if you want to be able to pipe something in at build time. And then finally, you would run your application exactly as you would locally on your system, Python app py in this example, but you just give it a command to run, and now your application is running in that containerized, encapsulated runtime environment. Now let's talk about how Docker build actually works. It's going to build the image according to the steps that you define. And you'll often hear something called Docker context. Context is the set of files in the specified path or URL. That's sometimes where you'll see the Docker build period, but people don't understand always what that period is. It can be confusing. So let's take a look at 3 examples. We're going to use an application called Tailwind Traders. Let's say that I'm in my home directory, Tailwind Traders website, and I run a Docker build source Tailwind Traders web command. That highlighted section is my context, which is why I can run this command and not need that period, because I'm already in Tailwind Traders website, and then my Docker files and my application files live in source Tailwind Traders web. That's the set of files in that path or URL. And then -T stands for tag, so that I can give my image a tag rather than just alphanumeric characters. Now this command will have the exact same effect as the command beneath it for Docker build -F. That's for you're giving it a specified file for your Docker file that has the set of instructions. And then what follows that is going to be where the set of files for those instructions live. In this instance, I specify in a very explicit sense that the file is source Tailwind Traders web Docker file. And then the .source Tailwind Traders web is the set of files or the path where everything from my application lives. Now, both of these 2 commands will have the same exact effect as this bottom command. The only difference is I have changed directories and dropped down into the source Tailwind Traders web. And now I can use the examples you'll find online, which is Docker build period, because now I'm in my PWD, or I'm in the current working directory where my Docker files and my path or my context files live. I specify the Docker file. This is helpful if I want to use multiple Docker files. Maybe I'm working on dockerfile.develop or dockerfile.net core 3.0, whatever I want to name it. I can have different Docker files and correspond with different paths for where those different versions live. This is helpful in development. All right, now I mentioned earlier that containerization is different from virtualization, right? A container is not a virtual machine, and here's why. There's 2 different types of virtualization. You either have your host operating system sitting on top of your infrastructure, and then your hypervisor sits on top of your OS, or your hypervisor sits directly on top of bare metal in virtualization, type A and type B. However, in both of those scenarios, you still have independent virtual machines. Your independent virtual machine is going to have its own operating system, its own dependencies, its own application deployments, and it's not immutable, right? It's not portable. VMA is going to differ from VMB and C and vice versa. However, in the container world, it's a little bit easier. It's actually a lot easier because you just have your host operating system on top of your infrastructure. You have a container runtime layer, which in this example on the right of your screen is Docker. We're using Docker for our container runtime. And then you run your containers with all package dependencies and your application right alongside it. So now that container becomes completely immutable, can't be changed, it becomes portable, and it becomes a lot faster, right? Because virtual machines are quite large. They can be 20 gigabytes plus. This can be a couple of megabytes. The smallest container image is 5 megabytes for Alpine. It's significantly smaller, which means it's significantly more fast. Now, let's just do a quick refresher on how container layers work in case you're still, again, Thanos' finger, maybe you're a little new. You can think of container layers like a cake. And here's why that's important to think of it like a cake. When you have your Docker file, you start off with your from, you maybe set a work directory, you expose a port, you do .NET build, .NET restore. Each one of those lines or commands is an image layer, and it's read-only. Sometimes, and I've seen this happen more than once, I've done it, we accidentally forget that anything that's read-only gets baked into your container, just as it would get baked into a cake. So think of that in the sense of if you accidentally bake in a connection string, a password, an SSH private key pair, something like, and it happens, right? We've all done it. And so we want to be very mindful of what we're baking into our cake. Anything that happens on top when the container is running is read writes. So if we happen to have some sort of malicious code and there's something baked into our cake, that malicious code could theoretically gain access and do something compromising. So we really want to be mindful of how our containers are being built and structured. Now, we've highlighted on some of these, but we're just going to run through this again. Here are some big benefits of using containers. For one, you have repeatable builds and deployments, right? Because now I have something that's immutable and portable. I don't have to have it works on my machine, it doesn't work on your server. We don't have to have that argument. It works wherever I put it. I can build a container on my Mac, I can run it on Linux, I can run it on Windows, right? It becomes something that's more portable and repeatable, so it gives me an added sense of reliability. I also have a significantly faster starter time, right? Because we talked about how much smaller it is. Also, with reduced size comes a smaller attack surface, so it also offers a potential for greater security. You can also package your dependencies, as we mentioned, not you can, you do. You package your dependencies alongside your application. And this is my favorite right here. As we've mentioned, containers run everywhere. And depending on where you're watching this, I like to say in the States that containers are kind of like Oprah. If you have a Mac, you get a container. If I have Windows, I get a container. If I have an IoT device, you get a container. Raspberry Pi, you get a container. Everyone gets containers and they all work. It's absolutely fantastic. Now, I want to talk about this Tailwind Traders application that we briefly touched on just the structure of that Docker file, but I want to talk about how it works. So you have your little user that's going to go and hit the Tailwind Traders website. And Tailwind Traders, by the way, is a fictitious storefront where you can go and buy homed goods. You can buy, coffee tables. You can buy kitchen tables. You can buy coffee machines. You can buy garden gnomes. You can buy a lot of really fun stuff. And you would hit the web front end. Now, this is something that's deployed on Azure Kubernetes Service, so AKS. And there's 11 different microservices. We only have a handful of the ones that you don't see some of the mobile stuff happening in the background, but we have a handful of the ones that we're going to be working with today on the screen. So our web front end is a hybrid application. It's kind of a mix of .NET Core 2, .NET Core 3, there's some React in there. And then there's the backend framework, which has various APIs. You have a coupons API in Node, you have a stock API in Java, products API in .NET Core, popular products in Go, a profile API in .NET Core, right? We have a lot of different APIs. Now, the hard part is when we do start getting into this world of containers, from a developer standpoint, especially when we're just trying to understand Docker files and Helm charts and all of this, where do we go, right? How do we sit here? All I want to do is I want to debug this API, but I need to see it in the context of the larger application. And I'm still really new to this microservice world, so I'm not really sure how to debug this or have insight into this. This is probably one of the most common questions I get asked. By the way, we also have a products API and a shopping cart API. There's a bunch of different APIs. So right here over on the bottom left-hand corner, you can see I have my developer workstation. This is going to be what we're going to work with today. And I'm going to focus on the cart because I've just been informed that we have a bug in our shopping cart. Whenever somebody goes to try to buy an item, no matter what the item is, they get a garden gnome added to their shopping cart. And so I'm going to show you how you can use VS Code to debug your application, even your single API, if I'm only working on cart, which is written in Node, even if I would have to normally hit that web front end. So I'm going to actually have my own little isolated environment as a developer where I don't need a Docker file, I don't need a Helm chart, and instead I could just replace that cart API, not in a production scenario. I replace it in my own isolated environment with my own isolated FQDN to be able to start testing things out and fixing it. Let's check it out. So I'm currently working within the cart API, and I'm using the local process for Kubernetes extension, which allows me to debug on my local system without needing to worry about Docker and Helm charts. So let's go ahead and check it out. First thing, we can drop down and you can see I have a shopping cart model right here that we're going to be working with. Let's take a look at the problem. I'm going to go ahead and click on the little Kubernetes down here at the bottom, and I'm just going to choose to route over to my ingress controller. We're going to go drop something into our cart. You can see that I've already tried this a few times. We'll just drop this wooden table into the cart. We'll simply click on the cart. And it seems that every time I try to shop, I get a garden gnome added. So let's see if we can debug this without having to worry about Docker and Helm charts. The first thing I'm going to do is I'm going to use my same local debugger, my launch program, which would just launch this particular API locally on port 3000. Only instead, I'm going to launch it with Kubernetes, and I'm going to do so isolated. So what that means is once this starts up, it's going to redirect the service traffic, but it's going to isolate that service with my own prefix. So I'll be able to start working and debugging this in my own specialized environment, in my own fully qualified domain name that's not going to interrupt any traffic on the actual root domain name. All right, so you can see this line right here. It says the container port 3001, which is actually what we're exposing in our Docker file. And you can see that right here in Docker file, we're setting an environment for port, and then we're exposing that. That's now available at localhost 3000. So now that that's available, let's go ahead and click on shopping cart. And you can see I have an initial sync call. I'm finding email. I'm starting to query the Cosmos DB that we have in our application stack. And I have right here on line 51 an add item call or function that's actually, again, when I'm adding an item to my cart. So I'm just going to set a breakpoint right here on line 53. I'm going to click Kubernetes down here at the bottom, and you'll notice I have now my new isolated, fully qualified domain name with a prefix of Jessica D and some random numbers. I'm going to click that, and that's going to take me to my very own URL right here, right? We can see Jessica Dean 7091, and then this was the actual root domain. So this is going to be my own environment where I can start to see what's happening here, and I can actually hit a breakpoint. So I'm just going to add this microwave. And just like that, I hit my breakpoint, you can see right here. And now I can hover over this, and I can actually see the detail of what's being sent. You can see here's the detailed product. Sure enough, it's sending a single red garden gnome. Now let's go over to our debugger and see the call stack. You can see the add item is part of it, process ticket, and then there's another add product, which is actually a different file. Now this appears to reference this shopping cart add item right here. If I scroll up a little more, I see the actual add product. And I see that I'm also supposed to have request, and it looks like myself or another developer had actually hard-coded a body call to test something. And unfortunately, that got pushed into production. I don't know why we were choosing a red garden gnome, but I think we were checking to make sure that this function was working. So rather than having item equal to body, I want it equal to the request, to the body request. So I'm going to save, and just to be safe, I'm also going to comment out this other const, and we're going to go ahead save that. Now I will restart the debugger, and we'll close this cart controller. Let's go and double check. We'll leave our breaking point right now on our return. Let's head back on over here. We'll refresh, and we'll retry to add that item to our cart. And I left the breakpoint because I want to see what the actual call stack is. So we hover over this now. And if we click on our detailed product and drop down, I now can see that microwave is actually being sent, right? So it looks as though we've resolved that. I can click continue and see what happens. See, it looks like microwave has now been added. Let's go take a look at our shopping cart. And it looks like now we're finally seeing our microwave. We'll go ahead and clean this up. We'll clear out all our garden gnomes and our microwave. We'll do it one more time. There we go. Now I'll remove this breaking point here. Okay, well removed. Go ahead and refresh. Head back over to kitchen accessories, go back to coffee maker, click add to cart. And there we go. Now I see coffee maker red has been added to cart. So I'm fairly confident in all this, but how do I have my same team have the same level of confidence? And this is something that's really cool. The same functionality that is built into VS Code is actually part of just Kubernetes on Azure. So for example, if I check this into a special branch, I'm on Jessica Gnome Fix, and I'm just going to say gnome bug fix, and I'm going to go ahead and commit, and I'm going to push. We can head on over to GitHub, and there's actually a PR workflow that will start once we open a pull request. So I'm just going to click open pull request. We'll make sure I'll move it into my repository. So I'll go from my gnome fix over into my main repository. I'll create that pull request, and a workflow will fire off. Now, the cool thing is what happens when that workflow fires off. Not only do I have an isolated environment, but there will actually be an isolated environment set up for this pull request. So everyone now on the team, whether they're a designer, whether they're a developer, whether they're operations, whether they speak code or whether they don't speak code, will still have the same level of confidence. You can see right here as it's starting to go through the build setup. It'll do a bunch of different things. It'll do Docker. It'll actually install via Helm. It'll set up routing labels. It'll handle everything as per this extension. And once it completes, we'll see our bot comment right here. There we go. You can see that the private version has been added. And if we zoom in here real quick, you'll see that now my prefix is actually equal to the name of my branch. So everyone gets the same level of confidence that I get from my local VS Code experience. All right, so that's probably one of my favorite demos to do just because it's so awesome. Again, it's probably one of the lowest barriers to entry because you don't need a Docker file, you don't need a Helm chart. Instead, all the code when you're working in the isolated environment redirects over to the code running locally on your system. There's actually no container involved, but you're still able to work with containers in Kubernetes from a traditional developer approach and have confidence in what you're doing. And more importantly, you get to share that confidence with the rest of your team, as we saw. Now, some helpful tips as you move forward in your journey. Again, this is a superheroes talk, so we're going to quote Gemma Simmons' Marvel Agents of S.H.I.E.L.D. The steps you take don't have to be big. They just have to lead you in the right direction. You don't have to leave here today thinking you're going to go master Kubernetes and Docker and you're going to write the next Helm operator or whatever. We don't have to go big, and we don't have to go jump and deploy Kubernetes. And sometimes Kubernetes might not be the answer. But if you are working with it, we have now learned some tools. We have the Docker extension, the Kubernetes extension, the local process for Kubernetes extension. We have learned small steps we can take to help lead us in that right direction. Also, ask yourself as you're moving along this journey, as you're building your Docker files, as you're crafting your microservices, is what you're thinking of adding in, is it going to add value? Remember, your end goal is, it's just a waffle, right? Your goal is to try to continuously deliver value and have that delivery mechanism. So ask yourself, does it deliver value? Or does this add unnecessary complexity to where there's not going to be any return? At the end of the day, it is just a waffle. So just keep it super simple. Some final recap points on some Kubernetes best practices, especially if you are moving into the Kubernetes world. We've focused on the value of building small containers, but it's also incredibly important. You can utilize multi-stage builds where often what you need at build time, for example, the .NET Core SDK, is not what you need at runtime. You can have the SDK compile your output and then copy that over and just use the .NET Core runtime at your actual run. That'll make your image significantly smaller. You can also consider your application architecture. Use namespaces, use Helm charts, utilize role-based access control. Not everything in your cluster or in your environment needs God mode. You can implement health checks. These are liveness and readiness probes that ping your HTTP for your pod that tells whether or not the pod is up and gets a 200 response, or whether it's 404 and then it can report an error. There's some sort of crash leak back off, something like that, right? We want to implement health checks to where we know whether we're healthy or not. Another best practice is to set resource requests and limits. This is the bare minimum of resources or C group information, CPU, memory, that your process needs. Your application probably doesn't need 2 gigabytes, right? The bare minimum might be 100 megabytes of memory and it maxes out at 512, whatever it might be. Set resource requests and limits appropriately. And then finally, be mindful of your services. Not everything needs to run inside your cluster. I'm a huge proponent for using database as a service, things like Azure SQL Server or Azure Cosmos DB, and you can link those easily over into your cluster. You can also not rely on load balancers. You can use proxies. Load balancers are expensive, both from a time management perspective and cost management perspective. So you can utilize various application routing methods to ingest traffic in through an ingress controller and then utilize routing in your cluster on the back end. Finally, my name is Jessica Dean. Thank you so much for hanging out with me. I'm here because, frankly, I love technology, I love community, and I love hanging out with engineers like you. I focus heavily on Linux, open source, DevOps, containers. Feel free to reach out to me anytime to talk about that, or we can talk about Disney, CrossFit, whatever you want. My last name is spelled with 2 E's, D-E-E-N, so there's no relation to James Dean, and you can find me on GitHub, Instagram, and Twitter. Finally, thank you very much. It has been my absolute pleasure to hang out with you today. Cheers.